Okay, what the question is, a converging lens of focal length 50 centimeters is placed coaxially in a contact with the other lens. Okay, if the combination behave as a diverging lens of focal length 50 centimeter, then find the focal length of the focal length and nature of the second lens. Have you got the question, beta? Have you got it, beta? A converging lens of focal length of 50 centimeters is there. Is placed coaxially in contact with the other lens. Other lens, I don't know, we don't know about the other lens. If the combination of these two lenses behaves as a diverging lens of focal length 50 centimeter, then what will be the nature and focal length of the second lens? Have you got this? I hope all of you can do. All of you can do this now? Yes, very good. Shabash. Done? It is very simple, isn't it? Instead of focal length, if you want to calculate the power, you can write the power also. So if you are relating it with this, find the power and the nature. Okay. Have you done? Very good. You have done, I think. 25. It is plus or minus, beta? Yeah, very good. It is minus 25 kilometer or light years or centimeters or millimeter, micrometer, Ah. And what will be the power? What will be the power? No, you can not write like this because centimeter is not the SI unit of the length. So power should be written in its SI unit, that is diopter, and the focal length will be taken in meter. Okay, in its SI unit, the focal length taken in its SI unit, and power in its SI unit is diopter. Okay,
Okay, sir.
have you done?
Yes, sir.
What the power is coming? Nature of the lens
That is it, minus 40.
minus 40.
No, minus 4, minus 40.
Minus minus 4 diopter.
Yes,
And what is the nature?
it is diverging.
Yeah, very good. It is diverging lens and power is -4. Very good. Now, can we go to the microscope? Optical instruments. So, in first of all, we will see simple microscope. Okay. What we need to see? Before that, we should know the visual angle. What is the meaning of visual angle? How much the angle an object is suspending on your eyes when you are seeing it. Okay. So if this is your eyes, let us see. There is an object. This object passes the light pass from your lens and form the image over here. Okay. On retina. Like this. So how much angle it is suspending, that is called visual angle. Okay, this angle is called visual angle. Okay. So how enlarged an object can be seen depends on this visual angle. Okay. If the object is very far, let us say object is over here, so it will suspend a smaller visual angle. If the object is get closer up to here, it will suspend a more visual angle. So visual angle decide how much the big an object can be seen. Have you got this? If the object is close, then it will suspend a more big visual angle as compared to the object which is far away. Okay. So, but up to what closeness from the eyes we can see the clearly? That is called least
Distance of distinct vision.
and that is we take D, which is equals to 25 centimeter. Okay. So it doesn't mean that how much close it is eyes to the eyes, because as you take it closer than D or closer than the less distinct or distinct vision, it will suspend a more angle, but you cannot see that clearly. Okay, so there is a limitation that how close you can see the object, or you can magnify the object how closely you are taking it with the eyes. Okay, so if the object is very far, you are not able to see that clearly. So what you do, you take it near to the eyes. But what you are doing at the time, you are increasing the angle of the visual angle to see it or to create its a bigger image. You can see if this is being closer, then this light ray will intersect over here, and this will form a big image as compared to the this one. As compared to this one, this light ray is forming a big. Have you got this? But there is a limitation. Before 25 centimeter, or then this distance or distance vision, you cannot see the object clearly. So this means how much the object is suspending the angle at the visual side or at the distance of this distant vision. At that point, you can see the object clearly or more magnified. This is the this is the most magnified case when the object is at least distance of distance vision, where it is forming um, biggest visual angle in terms of seeing it clearly. Okay, it can form a big visual angle, but in that case, You cannot see it if it is get closer to this distance of distinction. Have you got this, beta? Then in simple microscope, what it is nothing just a convex lens in a condition of where the image is formed virtual indirect. Okay, so it is nothing a convex lens in a condition where the image is formed virtual indirect means the object should be between F and O. Have you got this, beta?
Yes, sir.
Okay, so we have bring this object and we are our vision is over here. You're observing it from this side. Okay, so it is creating a big angle or a larger angle at our eyes as a for viewing it. This is our angle suspended by the image on our eyes. Okay, this is our the angle, visual angle suspended by the image on our eyes. Have you got this? Now the magnification of the simple microscope M can be written as visual angle suspended by the image upon visual angle suspended by the object at least distance of distinct vision. It is D. Have you got this, beta? So this we can say the beta and the initial stage when the object is at the least distance of distinct vision with the eyes. How much the angle alpha, let us say it is forming on the eyes. This is D. Then what we can write M is equals to beta by alpha. It is alpha and it is beta. Have you got this? What the magnification is for a simple microscope, that how much the image is suspending the angle or visual angle on the eyes, and how much the object will suspend a visual angle on the eyes when it is kept at a distance, least distance of distinct vision. Have you got this? Have you got this, beta? The ratio of those two is taken as the angle suspended A visual angle suspended on the eyes when it is kept when the object is kept at a distance least distinct of distance region. Have you got this? Alpha
Sir, could you
is the
explain that again?
angle. Huh?
Could you explain
What, Peter?
this again? I couldn't understand.
Magnification of a simple microscope is the basically the ratio of angle suspended by the image. Image means when it is forming through the lens or through the microscope. That we so call it beta. Okay. When the object was there, the image being suspending the same angle as the object was suspending at this point on over here on the lens. Have you got this? The ratio of the visual angle suspended by the image to the ratio of the and the visual angle suspended by the object when it is kept at a least distinct of distant vision for the eyes. Have you got this? This is the case for the alpha and this is the case for the beta. Have you got this? So if this is the object height and this is image height. Can we take this? Take beta. Can we take? Can we take beta? Okay. This is the object AB and this is or and this is B dash A dash. Here it is also the same height AB. We have taken the eye this object closer to the eyes or closer to the distance than the distance of least distant of distant vision. We have taken this object, so it is suspending a big angle, but at this time we cannot see it correctly, so that we have used this. Have you got this? To make its image far from this, but at the same angle. You can see these two triangles are similar. Triangle ABO and A dash B dash O are similar. What we have done? We have taken this object closer than the least distance of distant vision, but to see it clearly, we have made it image beyond that by using this lens. Have you got this?
Yes,
Have you got this?
sir.
Okay. Now, what the magnification will come in terms of their height and other things. Okay. So if we see the triangle, I can rub this. All of you have taken. Can I rub this?
Yes, sir, sure.
If we see the triangle, yeah, what if beta and alpha are small? They were very small because microscope is used to see the smaller objects, or we used to see the elephants. Smaller objects. Very good. So the angle suspended will also be smaller. Are smaller angles, isn't it? Then tan beta can be taken as beta. From here, tan beta can be written as hi over v or x, whatever the distance you want to take. It is forming at a x distance, uh, kept at a x distance. Okay. So h, height of an object, o upon x. We can write x from this triangle. Beta can be written in this form. Okay. Similarly, tan alpha is also being very small, can be taken as alpha is equals to H naught over D. Can we take this? Can we take this or not?
Yes, sir.
Or if we see the triangle, the bigger triangle, in triangle A dash, B dash, O, or it is through triangle A, B, O, A, B, E can. So if you see, we can also put this value hi, but when we see the ratio, because they are similar, then we can also write in this form. In terms of image distance, we can also write, or in terms of object distance, we can also write this. Have you got this, beta? Have you got this? So this
Yes, sir.
image for this eye should be formed at D, because we can observe this image clearly for at a magnified way at D. Have you got this, beta? What, beta? This object very close to our eyes. It is was suspending a larger angle, but we cannot see it clearly. So to see the image of this object clearly, we have formed the image at D. Have you got this? Huh? Huh. Okay.
Sir,
And from here,
sir,
yes, beta.
sir, in tan beta is in that height of the image, right?
In both the height you can write image, or if you
Uh,
write for image, it will come out to be hi over D, and for this it will come out to be h naught over x.
so in H naught over X, shall we not write AB instead of HO?
Yeah, there is 2% battery anytime the class get over, but ask what you're asking.
For the height of the object, sir, shall we not write the AB instead of HO? Then we could,
AB.
yes.
We can write, but instead of that, I directly write it to save the time.
Oh, okay,
Okay,
okay, okay. Okay.
okay. So now, what the magnification will come out to be? M is equals to H naught x, that is beta, upon H naught D, that is alpha. Okay, magnification was M is equals to beta by alpha. Okay, and from here we can say that this was coming out to be. From there we can write D over X. Magnification is D over X. When the image is forming at least distance of distant vision. Okay, M is equals to, all of you can see now, D over X. When this is called when the image is forming at least distance of distant vision. Okay, the another case will come when the image will form at infinite, that is called the normal eye or relaxed eye condition. Okay, then we take the image distance to be how much? Huh? Ah, image distance will be V is equals to infinite in that case. Okay. Okay, the next we will see tomorrow. Okay, next class. So it is 1% only. Okay, beta. Tomorrow. I'm not getting your voice. It is being very low.
Sir, at 1 to 3, Sheen ma'am is taking class tomorrow.
Okay, so at what time? Decide at night or night at any time at night. Okay.
Okay, sir.
Okay. Discuss in the group and then tell. Bye for now. Allah Hafiz.